Right, a serious question. If you're looking at this video through your mock revision, this will be a topic you've just done really recently. So we want to use our series formulae to find this. It starts at 1 and goes to n, so you can use the formulae exactly as they are in the formula book and exactly as you know them. So first thing I'm going to do is split this up into its various components. Remember, the 3 can go in front of the sigma. And then I'm going to change these into their formulae. Now the R squared's in the formula book, if you don't remember it. The sum of R is not in the formula book, you have to remember this, so that's a half n plus 1. Okay, now I'm just going to add up n times. That's going to be n times n. Lots of n, and then I'm going to add up 19 n times, so that's going to be 19 n. Do a bit of simplifying. Okay, can I do any factorising? Well, yes, there's an n in every term, which is good because there's an n in our answer. Might as well multiply out some brackets while I'm here. Remembering you've taken n out as a factor. And then combine some terms together. And you should be able to get to n squared minus 5n plus 24. Have a check. It just wanted us to show that, so that's the form it required. Right, part B. So this is a slightly different question with series now. So part B, let's just change this so we can see it. Okay, we've now got a function which is defined as our series here that we had in part 1. And you can see these two things are almost the same. This time we're just starting at r is 0 instead. Right, so this time we're doing the sum from 0 to n. So our function is our sum from 1 to n that we found in part 1, plus what we get when we put 0 into that formula as r. So what do we get when we put 0 into form? We'll get 0 minus 0 minus n minus 19. Okay, we know the sum from 1 to n, that's what we found in the first part, so that's n times n squared minus 5n minus 24, and we have to subtract n, subtract 19. Okay, so our function was the series we had in part 1, but this time starting from 0 instead of 1, so we can do the term we get when we put 0 into that formula, plus our series from part 1, which went from 1 to n. We do all that, and now we know what f of n is. We want to find a minimum value, so now you turn to something you've learnt in ordinary maths rather than further maths. How do we find minimums? Well, to find minimums, we differentiate. So we're just going to differentiate this. Okay, that is differentiated. We want to find a minimum. Remember to find minimums and maximums and stationary points. We're going to make that equal to 0 and solve it. So if you solve that, you'll get n is 5, or n is negative 5/3. Now, n can't be negative 5/3. N is the top of our summation here, which is from 0 to n, and so it has to go up, and it has to be an integer. So that one's not possible. So therefore, n equals 5 when we are trying to find the value for n, which has its minimum value, which was part B. Okay, so now we found that n is 5, and now we want to write down the minimum value of f. So in part B, we found n is 5. Now we want the minimum value of f. So that basically just means put n is 5 into our function. So I want to find f of 5. If I take my function that I found in part B and just substitute 5 into that. And therefore our minimum value is negative 144. This is only worth 1 mark, so you either get it right or wrong. That's that.